All right, let's get right into it. We're talking about how AI is going from these crazy one-off coding experiments to becoming a full-on development ecosystem. It's a huge leap.
So picture this. What if you took 16 AIs, right? Not just one, but 16 of them. You give them a shared folder to work in, and then you hand them a single, absolutely massive prompt. And that prompt? It's to build a C compiler. From scratch. Seriously. And get this, no humans allowed. No supervision, no guidance, nothing. Just the prompt, a really simple script, and 2 weeks to figure it out.
The result is, well, it's pretty staggering. You get 100,000 lines of Rust code, a working compiler that can actually build some seriously complex stuff. We're talking things like the Linux kernel.
But honestly, the code itself, that's not even the coolest part. What this experiment really gives us is this fascinating and, kind of chaotic peek into the future of software development. Okay, so first things first. How in the world did they actually pull this off? Because this wasn't just some small win. This was a real, honest-to-goodness breakthrough.
And you can see here the progress wasn't a slow crawl, it was a massive jump. The researcher, Nicholas Carlini, he tried this exact same experiment before on older models, and nothing. But then look at that last bar. Anthropic's newest model, Opus 4.6, just nailed it. It built the compiler. Same setup, same prompt, the only difference was a smarter AI. That's a huge deal.
Now you'd think trying to manage 16 AIs at once would need some super complex system, like a master planner delegating tasks. But the reality? It was, and I'm quoting the researcher here, comically simple. It was literally just a bash script running in a loop. And to stop them from tripping over each other, they just used a simple text file as a lock. Super low tech, but hey, it works.
But this is where it gets really interesting. Because when you let these things run wild without any human oversight, you get some pretty spectacular failures. I love the analogy. It's like trying to manage 16 brilliant but very weird interns. So the problems they ran into were all over the place. The AIs will get totally lost in useless data. They call it context window pollution. They had zero sense of time, so they just waste hours running tests instead of actually coding. They kept overwriting each other's work. And my personal favorite, one of them just, it turned itself off.
And this example is just perfect. It shows you the kind of weird bugs you get. One of the AIs literally ran the command pkill-9 bash. Now, if you're a Linux person, you know that just kills everything, including the script that was running the AI itself. It's not like some sci-fi robot rebellion. It was just a plain old dumb software bug. It just happened to shoot itself in the foot. Okay, let's double-click on that drowning in data problem, because this is super important. It's called context window pollution. See, a human programmer can look at a giant log file and our brains just automatically find the one error line. An AI can't do that. It gets completely lost in the noise. So the team had to redesign their tools, not for humans, but for AIs, with super short, clean error messages. That's a huge shift in thinking, right? And look, this whole memory issue, it's not just some nerdy academic problem. Figuring this out is the key to making AI agents actually useful in the real world. And what's wild is that the whole industry seems to be landing on the same really simple and elegant solution.
And if you need proof of how valuable this solution is, just look at a company called Manus. Meta reportedly bought them for around $2 billion. And their secret sauce wasn't a better AI. Nope. It was a better way for the AI to remember stuff. A simple technique they call context engineering. So here it is, the ridiculously simple but powerful solution. A 3-file pattern. That's it. Instead of trying to stuff everything into the AI's tiny short-term memory, you just write it down. You have a task plan file for the big picture, a findings file for notes and research, and a progress file to keep track of what it's already done. It's basically an external hard drive for the AI's brain.
The big idea here is so simple but so clever. Just think about it like this. The AI's context window, its short-term memory, that's like RAM. It's fast, but it's small, and it gets wiped all the time. But the file system, these simple text files, that's like your hard drive. It's permanent, it's huge, and it's reliable. So anything important, you just save it to the disk.
So this simple little idea, using files as a memory, it has absolutely exploded. It's not just a clever trick anymore. It's become the foundation for a whole ecosystem of serious professional tools for AI developers. Just take a look at this project. It's called Everything Claude Code. It's a whole toolkit built on these exact ideas. You've got specialized agents like a planner or a code reviewer. You've got specific skills that teach the AI how to do things like test-driven development. And you have these simple slash commands to kick off really complex jobs. Folks, this is what pro-level AI development is starting to look like.
And you can tell this whole ecosystem is growing up fast. I mean, to make sure it works for everybody, the developers rewrote all the main scripts in Node.js. Why? So it runs on everything: Windows, Mac, Linux. That's a huge sign that this stuff is moving way beyond just a weekend project. This is becoming serious, professional infrastructure.
All right, so for our last section, let's just zoom out for a second and think about the big picture here. What does it actually mean when an AI can churn out 100,000 lines of code that kind of works? Well, it brings up a whole new can of worms, a whole new set of challenges.
Look, we got to keep it real about the limitations. The compiler the AI built, it generates pretty inefficient code, worse than the standard GCC compiler on its lowest setting. The Rust code it wrote is fine, it's reasonable, but it's not what an expert would do. And the lead researcher himself admits they've pretty much maxed out what this version of the AI can do. But, and this is a big but, it can compile and run Doom. And let's be honest, that's the real benchmark for any compiler, isn't it?
But this is the part that really gets me. Nobody designed this compiler. No human being sat down and made the big architectural decisions. No one debugged the really thorny code generation bugs. The AI did it. All of it. Now, it did it badly sometimes and inefficiently a lot of the time, but the point is, it did it.
And that leads us to the final and maybe the most important question. The researcher himself brings this up. For something like a C compiler, correct is pretty black and white. It either works or it doesn't. But what happens when we start using these AI agents for projects where the definition of correct is fuzzy, where your tests can't possibly cover every little thing, and where the whole point was to take the human out of the equation? Yeah, that's not a hypothetical question anymore. That's exactly where we're going.